Today we will be talking about density. Density is a very important concept in our scientific world. In your lab report, I'm going to talk momentarily about what you could include in your introduction. Density is the concept that all matter has a relationship between its mass and volume. And density can be calculated by taking an object's mass and dividing it by its volume. There are some things that is good to know. Mass is measured in grams and volume in cubic centimeters. But it's also nice to know that 1 milliliter is equivalent to 1 cubic centimeter. We will use this to help figure out the volume of an irregularly shaped object. When we write your introduction, you give some background information, like density is one of the reasons why we have convection currents. As an object increases in temperature, its volume increases, but the mass stays the same, therefore making it less dense. And objects that are less dense tend to rise. Objects that are more dense tend to fall. Now, in today's experiment, we will be using several materials. In your lab report, you have to determine a hypothesis in the form of an if-then statement. For example, once we calculate and figure out the densities of some of these materials, could you say if material A was placed with material B, material A would rise or material B would sink in such material based upon its density. In today's experiment, we will be using a digital scale that measures to the nearest gram. I have a calculator to calculate the densities. I have what's called a caliper. A caliper helps us make measurements in centimeters, and this can make measurements to the nearest 0.1 centimeters. I have a pencil. I have a dry erase marker because I have a table drawn on a dry erase board that you can watch. I have a graduated cylinder up to 100 milliliters. I have beakers 1 and 2 that we will use, and in beaker 3 I have colored blue a water sugar solution or sucrose, and in beaker 4 I have a water and salt solution, and we will calculate the densities of those liquids. Now, our other materials is a yellow foam cube, a cube of wood, and a rock. And because safety is always a consideration in almost any experiment, because I have salt and sugar water, I wouldn't want something to splash up in my eyes, I will wear a set of safety goggles to ensure that that does not happen. So since density has to deal with mass and volume of objects, we are going to need to calculate those things. I have constructed a table like this, and you should construct one very similar in your lab report, where I have the object listed, I have the mass, the volume, and then the density. And the mass is in grams, the volume in cubic centimeters, and the density will be calculated in grams per cubic centimeter. I had the mass of beaker 1 and 2 labeled because we are going to use them. So my first step would be to gather all the materials that I need in order to conduct the experiment. Since I will be using beakers in 1 and 2 to determine the mass of certain liquids, I'm going to need to determine the mass of these beakers because I'm going to have to subtract that when I determine the mass of the beaker with the liquid in it. So the mass of beaker 1 is 66 grams. My next step would be to take the mass of beaker 2, and it is 64 grams. So in my table, I have H2O, or water, as my first. Water is my control in this entire experiment because it gives me the base comparison for densities. And if my calculations are correct, here I have a graduated cylinder full of 70 milliliters, which would be equivalent to 70 cubic centimeters. So I have that in here, and I will take beaker 1 in this step and place it on the scale, and that is 66, and I will add 70 milliliters to the beaker. When I add 70 milliliters to the beaker, now with the water in the beaker, the mass is 134 grams. I would write that on my table, but I would have to take the mass of the beaker, which is 66 grams, and I would subtract that from 134 to determine the mass of the water. Then I have the mass of the water and the volume, which was 70 milliliters, and I am able to calculate the density. And density is mass divided by the volume. Mass divided by volume. Density is expressed in grams per cubic centimeter. The important thing to remember is that 1 milliliter is equivalent to 1 cubic centimeter. The next substance on my chart is water and sugar. So in beaker 3, I have a certain amount of water. What I will do is I will measure out an amount of water and sugar into my graduated cylinder, and then I will pour that into beaker 1. Making note, the beaker's 1 mass is 66 grams. In this step, I have 40 milliliters of the water and sugar mixture, or sucrose and water. And when I add those 40 milliliters into beaker 1, this mass is 126. Next on my list is the water and salt mixture. I will place beaker 2 on the scale. Beaker 2 weighs 64 grams. In this step, I will pour 80 milliliters of water and sugar, or water and salt mixture, into beaker 2. Beaker 2's mass is 64 grams. With 80 milliliters of water and salt mixture, the mass of the beaker and the water salt mixture is 148 grams. So now that I have that, 148, I will subtract the mass of beaker 2 to find out the mass of this 80 milliliters of salt and sugar mixture. So far, we should be able to fill out the mass and the volume. We are now going to move down to the wood block. Now, to calculate the volume of the wood block, we have to take its length times width times its height. And I will use a caliper to measure that. And this caliper shows that its length is 2.6 centimeters. Its width is 2.6 centimeters. Its height is 2.6 centimeters. So to calculate the volume of that cube, it's 2.6 centimeters times 2.6 centimeters times 2.6 centimeters. That will give us our volume in cubic centimeters. The mass of the wooden cube or block is 6 grams. Now I will calculate the volume of the white or the yellow foam block. And this measurement is 5.1 centimeters, 4.9 centimeters, and 5.1 centimeters. To calculate the volume, I would multiply those three numbers together to get the cubic centimeters. Here, I have the foam block on the scale, and it weighs 12 grams. So now that I have the mass and the volume calculated, I can determine these objects' density. Our last object is a rock. To determine its volume, however, will be kind of difficult because it is irregular. We will use this object and determine its volume through displacement. But before I place this rock into a graduated cylinder with an amount of water, I will get its mass, and its mass is 16 grams. I will then take the graduated cylinder and I will put 50 milliliters in the graduated cylinder. Now the great thing about milliliters and cubic centimeters, they're equivalent. So when I place this rock into the graduated cylinder, the water it displaces, okay, we know that when the rock goes in, the water level will go up. It's the difference from where we started at 50 to where we end, and we will find the difference of that, which will give us the volume of this rock. And this rock, once I place it into the graduated cylinder, the water level now reads 57 milliliters. So take our starting level, okay, and subtract that from our finishing level of 57, and we now have how many milliliters of water this displaced. This displacement in milliliters is equivalent to cubic centimeters. We have taken the mass and the volume of several different objects. We need to know the mass of beaker 1 and 2 in order to subtract that when we calculated the mass of the fluids that are in there. We use a graduated cylinder to calculate the volume of an irregularly shaped object. You now have enough data to calculate the densities of the liquids and of the two cubes as well as the rock. One of the things that could be a source of error in this is that I have used a graduated cylinder, but I didn't dry it out every single time. So that could change the amount of actual fluid that I deposited into these other beakers. Another source of error is the fact that my scale only goes to the nearest gram. As we write a conclusion, when you formed your hypothesis, you may have selected whether or not a certain object would float or sink in a certain liquid. You can calculate and compare their densities to see, and your data would show that the less dense an object is compared to its surroundings, it will float. For example, water has a density of 1. If the density of this block is less than 1, then it would float. If it is more than 1, it should sink. In your conclusion, also talk about how important density is to many other things in our world. Thank you for your time.